Good afternoon, my YouTube video. My YouTube viewers. It's Crystal here. I am here to make another video for you, and the video that I'm going to make is going to be on the Leinhardt data set. And let's see if I can find it. The correct spelling, Leinhardt. Yeah, the Leinhardt data set. So I spelled it correctly, and we're going to do linear regression. And the thing is I started studying machine learning before I was studying statistics. So I didn't know this, but with machine learning, linear regression started out with statistics before it was in machine learning. So that's something that I found out since I've been studying statistics. So whenever you study statistics, they will have linear regression as part of their course curriculum, because linear regression was part of statistics before it was part of machine learning. So that's interesting. So we're going to work on the Leinhardt data set. And the first thing that we're going to do is we're going to import the libraries that we're going to need to do a linear regression on it. We're going to import pandas, which is going to create your data frame. We're going to import pandas as PD. We're going to import NumPy as NP, which is going to perform numerical computations. We're going to import stats models for the linear regression. We're going to import SciPy to perform scientific computations. We're going to import Seaborn for statistical visualization and Matplotlib for normal visualization. So the first thing we're going to do is we're going to call up the CSV file, which I got off the internet. And I'm not able to do this in R, and the reason why is because my compiler will not allow me to read files off the internet. If it did allow me to read files off the internet, I certainly would do it. But you've got an R online compiler that it will allow you to read files off the internet. But since this was a rather complex case and the visualization, in my opinion, wasn't very good, I decided not to do that. And so we use pandas to read the data set into the program, and then we define our columns. So data.columns equals country, income, infant, region, and oil. So country is what country it is. Income, I think, is the average income of the people in that country. Infant is your infant mortality. Region is what part of the world it is. And oil is whether it is an oil producing country. So what we do is we have some null values. We've got 4 null values. So we're going to drop 4 of those null values. And then when we drop those 4 null values, then you can see we don't have any more null values in the data set because we've dropped the null values. We use Seaborn to create a pair plot, and this pair plot does it on income and infant. So you can see the pair plot on income and infant, and you can see that both the income and the infant are highly skewed to the right. So here's a histogram of income, highly skewed to the right, and a histogram of infant, which is highly skewed to the right. And then now what I decided to do was a QQ plot. If I had, so that's your QQ plot, it doesn't look that great to me. And then if you had a 45-degree line, then you would see that it wouldn't work. Let's see. I'm going to try this. It's just taking a little while for it to work, but hopefully I got the code correct. It's just taking a little while. I don't know what the problem is. Let's see what happens. So it is working. So I'm not just sitting here talking for the sake of talking. So this is a good way to work it, because it says explain error, and then you have Gemini, which is in Google Colab now. So it says line equals 45. So let's try that. Let's try that. So you can see what happens when you got your line is 45 degrees, and that's why I had originally taken the line out. Okay, so that's what's happened to it. And so now we're going to check oil is oil. And so this is your scatter plot between the log infant and the log income, because if you get the logarithm of the infant and the income, it does look much better, as you can see, because here is a scatter plot without the logarithm, and here is the scatter plot with the logarithm, and so it looks much better. So we're going to make a histogram of log infant, so you can see the histogram looks better, the income looks better. We're going to do another QQ plot. So you can see there's your 45 degree, but you can see that the QQ plot does actually look better when you make it a logarithm. So even though it's not great, it's better than it was. So now we're going to define model 1. And model 1 is going to be the formula. X is going to be your log income, and Y is going to be your log infant. And so we're going to use a formula. So model 1 equals smf.ols, formula equals X, squiggly Y, data equals data.fit, and then we're going to print the model 1. So there it is with the logarithm. So you can see the summary of what it is with the logarithm. And then we're going to check for the residuals. There's your residuals. And the residual is the difference between the observed value and the predicted value. And then so now we're going to make a scatter plot of the residuals. So here's your scatter plot of your residuals, and you can see that we have 2 outliers on the top. So now we're going to check model 2. So features is going to be log income and oil, and then X equals log infant, and y equals data log infant, and x equals data features. So model 2 equals smf.ols, formula equals y squiggly log income plus oil, data equals data, and then you're going to fit it. And so here is model 2. Here are the residuals for model 2, and you can see the residuals when you include the oil are more than the residuals when the oil isn't included. And then now we're going to get the means. So the mean for 0.1 is 0.002, and the mean for model number 2 is 4.425. So I'm going to say that for model 2, the residuals are higher. And the higher the residuals, if you've got high residuals, then you're going to have outliers. So you can either use this with the oil or without the oil. And I did a regression first without the oil and secondly with the oil, and you can use whichever one you like best. But I think that the residuals are lower without the oil than they are with the oil. So we've covered the linear regression for the Leinhardt data set, and this is with statistics. And it's very interesting indeed. It's interesting to know that linear regression was part of statistics before it was part of machine learning. And so I'm going to go ahead and conclude this video because I've been talking for 12 minutes. So we've covered a lot. We covered the 45-degree angle on the QQ plot, and so that gives you an idea of what the XY variables are on the QQ plot, and they don't look that great in my opinion. And we've covered the two models, the model without the oil and the model with the oil. We've covered the residuals. So we've covered quite a bit on this. So I'm going to go ahead and close this video. If you like my video, please like and subscribe. And thank you so much for watching my video and learning a little bit about how I do statistics and machine learning. I look forward to making another video for you very soon in the near future.